Titration, titration, titration. All the titration calculations are the exact same. The only thing that we're doing is we're switching out the titrant that's here in the burette. So it's still concentration based, it's still volume based, but we're just using different things to titrate with. That's all that we're doing here. So let's review the calculations about what we need to do when we calculate the concentration of water hardness with these samples. So first off, we are using EDTA as my titrant, right? And this concentration will be given to you. This concentration may be a 0.000934 molarity. Whatever that concentration is, we will provide that to you on the board when you come in and do these titrations. So be sure to write it down. Okay, so I get this EDTA and I fill it up for my burette, and then I slowly drip, 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 drip until my color change happens. So let's say that my color change happens at a certain volume. And let's say that that volume is 13.2 milliliters. Okay, well, this is the volume of EDTA that it took, and this was the concentration of EDTA that was made. So I need to somehow relate EDTA to my moles of calcium, right? And we know that this is a 1-to-1, but it's a 1 mole to 1 mole. So with this calculation, I've got to convert over to mole, or this is not going to work for me. So molarity is equal to mole over liter. That is the molarity formula. That's what I'll always start with when I see this big M here that's involved. All right, so I know what this molarity should be. So I'm going to erase that, and I'm going to put a 0.000934 because that's the concentration that was made. Well, the moles, I don't really know. That's what I'm solving for, right? If I can figure out moles of EDTA, then I can get to mole of calcium. Well, my liter, I know how many liters of EDTA that it took, right? I recorded it in milliliter, but that's not a big deal for me to convert that over. So I take 13.2 and I divide by 1,000. And what I end up getting is 0.0132 liter, right? So I take this, I divide by 1,000. That moves the decimal over 3 times. And that gives me liter. 13.2 mils is 0.0132 liter. So now I can take these two numbers and I can multiply them, and this will allow me to calculate the number of moles of EDTA that I have. So 0.000934 times 0.0132, and I hit enter, and I get 0.000132, or 1233, if I round that off. 0.000123. That was pretty good, if I say so myself. That wasn't planned. Okay, so this is the number of moles of EDTA that it took to titrate this sample with. But you know what? It's also the same exact moles of my calcium as well, because it's a 1-to-1 ratio. So this is 0.00001233 moles of calcium. Alright, so now I need to figure out how on earth can I get to this ppm value, right? Again, ppm is milligram per liter. Well, here I've got moles of calcium, but I need milligrams of calcium. Alright, so I can go from mole to gram. But in order to do that, I need the formula weight for calcium. And then I can go from gram all the way to milligram, but in order to do that, I need to multiply by 1,000. So this gives me kind of the pathway that I need to take with these numbers. Now that I have moles of calcium, I can then change that over to grams of calcium and then milligrams of calcium, and that really provides me with this milligram number that I need to report water hardness with. So before I go any further, I just want to show you a picture of what this endpoint for the water hardness titration should look like. So here is this pinkish rose color that the EBT will start off looking like. And then this is the bluish color that you will end up with. Now notice it's kind of blue purpley, right? Or a lavender. Some people like to call this lavender. But this is the color change that you're after. You've got to be really careful with the color change. If you go too quick, then you might not see this color change happen. Or if you go too quick, it might stop at this position, which is more purple than it is blue. We want the bluish hue. We do not want any lavender or purple to stay behind, okay? So here's another example of an EDTA. So this is before the sample is titrated, and this is after the sample is titrated. So you see it goes from the pinkish rose color again to the bluish color that we are after. You do not want purple to stay behind. Okay, so now I need to figure out how can I go from moles to gram, and I need the formula weight. Well, I need the formula weight for calcium. So here's calcium, Ca, and then if I go and look at it on the periodic chart, it's going to be located right here, and the formula weight for calcium is 40.078. Alright, so I'm going to write this over here to the side. Formula weight for calcium is 40.078 gram per mole. That's what formula weight means, right? Okay, well, guess what? I've got my moles. 0.00001233 moles over 1. Remember, to set up dimensional analysis, I always put it over 1. Mole on top, mole goes on the bottom. Well, I'm trying to convert over to gram, and I can do that if I know the formula weight for what I'm using. Well, formula weight for calcium is 40 grams for every 1 mole. That's what that gram per mole means. So 40.078 per 1 mole. Now I can't stop there. ppm means milligram, right? So I'm going to have to convert my gram over to a milligram. Gram on top, gram on the bottom. I need to go to milligram. So there's 1,000 milligrams in 1 gram. Alright, so there's the setup. Then I'm going to come through and use my calculator, 0.00001233. Then I'm going to multiply by 40.078. And then I'm going to multiply by 1,000. And I'm going to end up getting 0.494. So 0.494 milligrams of calcium. Okay, but notice this unit. ppm means milligram per liter, right? So now I have the milligrams. That came from down here, 0.494. Now the issue is, what do I use for my liter? Well, I didn't use a whole liter of water to titrate. That would be stupid. I only used 50 milliliters, which is how my directions are written in the lab book. Well, whatever sample size that I decided to use here, I need to convert that over to a liter, and I need to use that sample size number for this calculation. So if the lab told you to use 50 mils, you would use 0.05. If the lab told you to use 100 milliliters, you would use 0.1 for the liter. Well, this lab is going to tell us 50 milliliters. So 50 milliliters is 0.050. So to calculate ppm, I'm going to take 0.494 divided by 0.050, and I hit enter, and I get a ppm value of 9.88 ppm calcium. Okay, so those are the calculations that you will be doing in this lab. And depending on the number of water samples that we might get submitted for that semester, you could be titrating anywhere from 10 to 30 water samples. And we would prefer you to do this more than once. So if our second year people cannot go in and titrate these samples and pick up from the instrumentation portions, you might be required to do those titrations yourself. So that means replicates. One time is not good enough, right? One time doesn't mean anything. Two times, and they're close, that's coincidence. Three times, now we're talking. Okay? So you have to at least titrate them at least twice, unless we tell you otherwise. But these are the calculations that you will go through as far as the EDTA calculations are concerned. Now in the next video, we will take a look at the Excel spreadsheet. What do we want? What should the Excel spreadsheet look like? Because what you'll find out is that if you have to do 20 of these, you don't want to do this by hand for all 20. You want Excel to do this for you. You want to enter it in one time and that is it. And then you want it to take it over. So that's what we'll look at in the next video. Be prepared. Get your Excel ready. We're going to be entering in equations left and right.